Hello, everybody, all around the world. It's my pleasure to be drawing this second section of the Microbit Live conference to a close, talking a little bit about how the Microbit tech team thinks about what we do in technology and how we make technology deliberately distinguishable from magic. Before I leap into those slides and an update from the tech team, I just want to say how exciting it is to have all of these people, all this energy online in a virtual conference again this year, talking about the creative, exciting, incredible things people are doing, teaching with the microbit, and kind of spreading the word about what microbit can do and the impact we can have when we work together as an ecosystem. So I thought this year it would be really nice, as well as giving you an update about what we're working on in microbit, to give a bit of perspective about how we see our role. So we're going to talk first a little bit about technology and magic and why we think that distinction is important. Then I'm going to talk a bit about some of the things we've been working on. So data logging, a new microbit Python editor that's currently in alpha and will be launched next year. Microbit v2.2. So the 2.2 is very small there. And then just a bit of, not what we're actually working on, but some things that we're thinking about. So what's coming in the future? Who are we collaborating with? And last, but perhaps most importantly, an invitation to come and collaborate with us on all of this discovery, working out how we can make microbit even more effective, even more fun, even better. So technology and magic, what am I going on about? So I think a lot of you will have seen this quote before. It's very popular in the technology world. Any sufficiently advanced technology is indistinguishable from magic. And it's often used as a justification for why technology should feel and be magic. And that's great. Actually, magic can make complicated things look simple. Magic can be really fun. Magic is often intriguing. You get drawn in, you want to know what's going on, and it does engage people. We might all have the experience of being kind of drawn in by a magic trick and encouraged to find out more. But magic does also have some dark sides, and I'm not talking about black magic. I'm talking about sometimes the way you can feel at the behest of magic. So magic is not under your control. Magic, in many ways, is not meant to be understood, and it's not an empowering experience to be involved in a magic trick. Magic is a trick, and I like to use this phrase, magic is inscrutable by its definition. It's hard to understand. So if technology is like magic, and advanced technology feels like magic, what impact does that have for our mission to inspire every child to create their best digital future? And actually, as we look at those dark sides of magic, we can see that there can be some really significant impact to technology feeling magic. If technology feels inscrutable, if it feels like a trick, like you're not supposed to see behind the curtain, well, maybe you're not going to be inspired. Maybe you're not going to get involved. Maybe you're not going to feel empowered to start creating with technology. So I think one very important role that we have in the tech team and the foundation as a whole is to think extremely carefully about how and when technology should feel magical. And it means that we're constantly thinking about this balance between two things. On one hand, we want to present simple analogs of the complex magical technology that students see around them that help them understand them and expose what's going on. But actually, we also want to take those good sides of the magic and technology. We really want to make sure that people do have a magical, playful, intriguing, engaging experience using the microbit. So we want to take that kind of magical technology bit where everything just seems perfect and smooth and brilliant and use it to actually help expose what technology is. So I'm going to give you a really specific example that I've used for a long time in the microbit to explain why I think the microbit is an effective learning tool. And it is the analogy between a microbit and a mobile phone. So apologies if you've seen me present a slide like this before. But the microbit is in many ways the simplest analogy you could present to a mobile phone. It's got a screen, albeit a much simpler one. It's got some buttons. It's got wireless communication between other devices, and it runs apps, the programs you put on your microbit. So by being a very simple, understandable, controllable analog to a mobile phone, we help expose that magic. We help kind of open the curtain and show people behind the scenes of what's going on in a mobile phone. And taking this to another level of detail, let's look at the microbit display. At a technical level, that microbit display is a bunch of LEDs wired in a grid. And actually, it's important that we don't just, when we're trying to expose this magic, we don't just throw that straight in students' faces and say, go on, turn the right pixels on and off you go, with the raw electronics. We actually create this higher level abstraction. We say, yeah, you can turn each LED on and off, but we do a lot of work in the background to present that effective analog. So much of what we're doing is working out how to get that balance right. Likewise, we don't make students, constantly check the value on a pin to see whether a button has been pressed or not. We give them an event that can tell when the button has been pressed. But by kind of exposing these simple analogs to technology, we make it easy to understand and we make it less magical. But in order to do that, we have to do a lot of stuff behind the scenes to give this simple, kind of clear experience. So I thought I'd just kind of split that down into some examples. We've got the LED display, which is a really nice way of showing what a screen does. We've got block-based programming, which gives you a really simple introduction to logic, flow control. It's very clear, but you do understand how computers make decisions. Things like if statements, things like loops. An on-loud block is a really nice, simple example of what a smart speaker is doing when it's listening. And radio messages. We don't expose Wi-Fi on microbit. We don't actually typically, give students direct control of Bluetooth straight away, but we do provide a nice, simple example of how radio messages are sent and received. But then on the kind of magical side, we and our partners, Microsoft as well, present these incredible web-based editors that do so much just in the browser. There's a lot of magic going on there. The microbit drive itself is a bit of tech magic. The built-in sensors, actually in a microbit motion sensor, to detect that shake, you've got a really tiny, physically moving thing inside a chip. That's totally mind-blowing magic that's going on in order to enable this. And the simulator and the universal hex for microbit V1 and V2 to work kind of seamlessly together. So this is what we're always doing in the tech team, is trying to think, how can we present really understandable, clear examples of technology, and what do we have to do behind the scenes to make that happen? So now we can move on then to what we've been doing in that area recently. And I'm going to start with looking at that microbit USB drive. So I think you all know that the microbit is a USB drive. You plug it into your computer, it shows up as a microbit drive, and you can program it by dragging and dropping code onto the microbit drive. Brilliant. But often people then ask, well, if the microbit is a USB drive, why can't I copy things off it as well? Why can't I log some data on my microbit and just copy that straight off onto my computer? And that's a good example of where the magic breaks down. So with microbit V2, we've just been doing work in the last year to make that possible. So now you can get data off your microbit by reading it off that microbit drive. So the steps to do that look like this. First, you have to write your program in MakeCode or MicroPython. And you need to use these new log features, which are available as beta features at the moment. Then you put that program on your microbit. You go and log your data however you want, however your program has told you to log the data. Then you plug the microbit back into your computer, and you open this new file on your microbit drive called mydata.htm. And it's sitting there right there alongside the details and the microbit drive. So here's the mydata file. Let's just kind of simulate opening that up. Let's open that up. And inside this file, you can download. You get a CSV if you download this. So just your data as a CSV. You can copy the data out. You can get a visual preview of your data. And all of that happens just by double-clicking on the MyData file that's on your microbit drive. So I'm going to switch to a quick live demo now of doing this. So hopefully you can see my browser here. And we're going to create a new program. So I'm going to go back to MakeCode, create a new project here, and I'm going to call this data logging. And the way to access this data logging currently is via an extension. It's called Data Logger. If we put the Data Logger extension into our program, here we've got a new set of blocks, Data Logger, and we've got a lovely simple log data block. We've got another few that we're going to look at later. You can respond to the log being full. You can delete your log. You can set your timestamp, but we can take log data. And let's do that for a start only when we push button A. So on button A pressed, we're going to log some data. And I'm going to log some X values and some Y values. And the actual data I'm going to log is going to be from the accelerometer, the acceleration data of my microbit. So acceleration X, and I'm also going to log acceleration Y. So here's a super simple program now that's going to log X and Y values on my microbit. So I can download that, copy it onto my microbit. In the interest of time, I'm actually going to instead show you a program that I wrote earlier, this one here. So that does a bit more exciting logging. It logs X, Y, and Z values, and it uses this new every block. So we've got in the loops category, every 50 milliseconds, I'm going to log some X, Y, and Z values. And I've been doing that on this microbit that you've got here, and plugged into my computer. So if I look on my microbit drive, I've got a mydata.htm file. And if I just open that in this browser window here, you can see I've got all of my data, and I can have the visual preview. This here is when I tapped the microbit against the desk, so you can see I maxed out the accelerometer data. Now, the other thing that's really exciting alongside these data logging blocks is we've also added, if you want to log data over a very short period of time, that's great. But if you want to log data over a long period of time, you might not want the microbit's battery to run out. So we're also working, and these are still in beta, so you'll find them here on GitHub. We'll send some links in the chat afterwards. But if you add the new microbit power extension into MakeCode, so I can just take that URL, add it, and this obviously, when we launch these, they'll be much easier to access. They'll be in this list. But you've also got some power saving blocks that allows microbit to enter low power mode. So you can set which buttons will put you into full power, and you can request low power mode, which puts the microbit into a very low power sleep. So that's our work on data logging. And I think one really important thing to think about with data logging is that we think that data logging is a really important part of exposing the magic of sorry, I need to switch back to my slides, of AI and ML, actually. So, we set out with Microbit V2 to help make AI and ML clearer for students. And one of the things, this is a picture that Katie sent me as an example of one of the steps people get wrong when trying to do AI and ML. We skip all these foundational steps, and we think data science is actually also a really important foundational step in AI and ML. So we think this is a really key part of teaching that AI curriculum, is to know how you collect data, how you clean data, how you analyze it. Great, so that's data logging. Let's look now also at a new Microbit Python editor we've been working on. And I want to start on this by saying thanks to a bunch of the people that we've been working on this with. So you might have seen the talk yesterday by Babis and Pierre about frame-based editing work they're doing at KCL. It's been a fantastic collaboration for us to learn about Python. Also, the MicroPython team, University of Oxford have contributed with some of their students, and ARM as well have contributed a lot to this work through graduate rotations in the foundation. So here is our new Python editor. This is what it looks like. We've got a sidebar on the left. You've got your code on the right, and we've got this code structure highlighting, so you can clearly see kind of more clearly where you are in your code and help understand indentation. And if I just switch to my browser now, you can see this working live. What we've got here is an easy way to navigate and explore the features of the microbit. So if I click on this explore, I can look at loops, variables, logic, the display. So imagine I want to know how to just put an LED, scroll some text on the screen, or maybe show an image, a heart image. I can have a look at some of the images. So I can have a look at a happy image, and that tells me how to do it. And now I can insert this code into my program. So this is absolutely still alpha work. We're still working on exactly what this looks like, where the code goes, how the code gets inserted, can you drag it? But we wanted to show it to you now and encourage people to start using it. And there's one thing I'd really like to show you in this editor. It's this feedback button. So here, there's a feedback button where you can provide any kind of feedback you like about the editor. And we really encourage you to open the new Python editor, have a play with it, and just tell us, does it work for you? Who do you want to use the Python editor with? You know, what stumbling blocks did you come across? What ideas have you got to improve it? So feedback is really important to us at this stage. The other thing I kind of wanted to show is that we've worked really hard on making autocomplete feature here in this editor. So if I start typing, you start to get completion information about the features of the microbit, including documentation and a way to actually take me to see that documentation in the sidebar. So display scroll, and I can also get some help about how I want to do this. And I also am told if I haven't completed my function, I've got errors as well. And if I, even now, if I connect to my microbit and run this on my microbit, we can see I've now got the serial connection. So I can have a look at the program on my microbit. If I flash this to my microbit now, it's going to flash my program onto my microbit directly. And if I get an error, actually, rather than having to read the error off the screen in my microbit, I'm told exactly where the line in my program is that's caused the error and what kind of error it is. So that should help make life a lot easier for students using Python on their machines to kind of find what's going wrong when they have their programs. So we're really excited actually about how this is going to make the process of teaching Python a little bit smoother. So having shown you the editor now, I think I'd also like to talk a little bit about, you know, what's gone on behind the scenes here and what we're aiming to achieve. And actually, coming back to our magic analogy, one of the things we wanted to do was to show behind the curtain a bit more of writing code. So block-based editors are fantastic because they stop you making certain kinds of mistakes. They stop you making typos. They stop you making syntax errors. They stop you making incomplete function calls. But it's really important if you want to learn about coding to eventually learn about all of those things. So for this editor, we want to make something that supports people in educational contexts. We want to make learning Python easier, more fun, more approachable, and therefore, we hope, have an impact on the diversity of people excited by text-based coding. We thought it was really important to be able to discover the features of microbit. One thing that block-based editors do really well is let you kind of browse what you can do on the device. So we've worked on that. But it is not a block editor. It's very specifically designed for text-based coding because we think the only way to learn about syntax errors, code errors, logic, indentation, is by actually to expose students to those problems, but in a constructive, supportive way, rather than a way that makes people feel confused and frustrated and like they don't understand. So that's a really important thing for us with this editor. We've also made a number of important developer-focused changes. So we wanted to bring the Python editor onto a modern tech stack to make it easier for a wide community to contribute to. But we also are building it in a modular way that means anyone else building exciting MicroPython editors for the microbit can take what we've done and use it in their editor. So be that EduBlocks or KCL or someone else building a MicroPython editor like Furia Labs. We want to do, key plumbing so that all of you that are building editors can benefit and kind of stand on our shoulders there as well. Right, and then just to clarify the audience for this, we're aiming at children in secondary schools, ages 12 and above at the moment. And as we go through this alpha process that we're going through now, we're going to be doing some user research on, really understanding prior knowledge required for using the editor. How kind of far back can we push it? It's going to work on tablet, but not mobile phone, because we think text-based coding really needs a keyboard. And we do want people to be able to achieve advanced tasks with it and use libraries and modules. So I think I've made this clear already, but it is absolutely, we're in alpha right now. It's very early stages. There's lots still to do. We're looking at search, how you can insert code, user research, and feedback. We want to make the errors even clearer with translations. And then we're really interested in hearing people's views on simulation. Once you connect your microbit over WebUSB, you've got a really smooth experience, quick turnaround, fast errors. We'd like to understand of the people that think they want to use this editor in that audience. Is simulation important? How would you use the simulator in a lesson, in a classroom environment? what would you use it for? What do you think you'd be able to do with this editor if you had a simulator versus if you didn't? And we'd love you just to use the feedback form on the editor if you've got thoughts about how and when a simulator would fit in this. So we're going through alpha now. We'll go into beta early next year. And the target currently is to release it in July 2022 and to leave the existing editor as it stands available for at least a year for everyone to use. If you've got books, screenshots, things that focus on that old user experience, we're not taking that away. We're just adding this as the primary editor. And the other thing to say, of course, is this will be done. We're not going to launch this if it's not ready. So while we're at such an early stage in the project, there's lots of possibilities for this to change. Okay, so that's our Python editor. And we hope that does help kind of take away some of the magic that goes on and people really understand how writing text-based coding works. So on to microbit v2.2. So the goal here is to communicate that v2.2 is just a response to a tricky problem that is affecting lots of people at the moment, the silicon crunch. So you'll have heard about car manufacturers, you'll have heard about PS5s being difficult to get hold of. And actually, we are not immune to the problem that's going on in the whole industry right now, that some parts are very difficult to come by. So microbit v2 is a v2.2, so it is a small revision of the microbit in order to resolve the supply problems. So here's a microbit v2. This is a microbit v2.2. So I've got, right, I'll hold up one of each to my camera. They are deliberately indistinguishable from each other. The main processor where the student's code runs is not changed. So users need not distinguish about whether they've got a v2 or a 2.2. There's no feature difference between the two of them. So there's, everything that a hex file that ran on a v2 run on a v2.2. What we've changed is the interface chip. So the thing that provides that microbit drive and the data logging has been replaced, and we've moved exactly the same software that was running on the old interface chip onto the new interface chip. So it behaves in the same way. And production has begun already, and we're expecting a rollout over the following months. So hopefully you'll should find that this keeps the microbit manufactured and available. The other thing to say is, as we've moved, ARM, who we collaborate on this DAP-Link software that gives that microbit drive, have worked with us, and they've actually ported that to GCC. So if you were someone who wanted to contribute, if you're part of the tech community and you felt you want to contribute to that DAP-Link software, you now can do it with the free compiler tools. So that hopefully should also open up a wider community around that. All right, so that's what we've worked on. Now, to keep things moving, what are we thinking about? So we looked at microbit v2 features, and we found that making sound, the playing sounds, was really engaging. People loved the happy, excited, twinkle sounds that we'd done with sound designers for the microbit. But actually, they were a little bit more magic than they were kind of explaining what was going on. So we've been looking, we think that on loud sound, that works really nicely as a kind of, it's the right balance between magic and exposing the magic. But we'd like to do a little bit more on helping people understand how they can make these cool sounds like happy, like twinkle, like soaring, that people love using. So we've been doing some research on some different blocks for making sounds in creative ways that can kind of go, make little chirps, warbles, clicks, and help people create those microbit sounds. So we expect some testing work and some beta programs about that later in the year. Next year. We also wanted to show you, if you didn't see the talk on it, the frame-based editing work done by KCL, looking at how you could make a frame-based editing to help the blocks to text transition. And if you're interested in that, I suggest you watch the video of the talk that was in Microbit Live yesterday. And actually, we had some students at Oxford looking at whether you can recognize the sound emoji or the microbit sounds on another microbit. So send messages over sound, or can you send Morse code? So we did some interesting research on that, and I think we'll be looking at how we can take that research and kind of underpinning prototypes and bring that through into the microbit editors, and also understanding how that's going to work in a classroom and an educational context, where it sits on that balance between magic and exposing the magic. And then there's also a talk on this editor in Microbit Live. This is some work also done with an undergraduate group at Oxford. Lorna's talking about this, I think, in the evening session today, or evening UK time, looking at kind of debug, how we can help and expose how we can kind of talk students through the errors. And it was based on this idea that in programming, often what you need if you've got a problem is just to explain the problem to a rubber duck. And if you explain the problem to a rubber duck, just in the process of explaining what's wrong, you'll realize the solution. That's it is a perfect button to see on this editor, because commonly just trying to explain what your problem is a step towards solving it. So we were interested in doing some research around whether there are ways in the user interface in editors that we can do to encourage students to think through and explain the errors and break them down. So that was also a really interesting kind of piece of research and collaboration. And this is just the tip of the iceberg of the kind of projects that are going on around the world. I'm aware there's stuff going on everywhere and kind of learning about microbit. But I thought I'd just expose some of the work to encourage everyone here to think about microbit not just as something which is done and finished, but as a platform that is always evolving and always learning new skills and always thinking about how we can use the capabilities of the microbit device to make teaching easier, to make technology clearer, to give students a greater mastery of what they can do with technology. Because that, I think, is fundamentally important to why the microbit exists and how we're going to help empower students to change the world with it. So finally, then, we would like you to come and help us with this. So the first thing you can do, if you're interested in anything that I've talked about today, and you're thinking, well, where will I find that? How will I know when it's time to test it? Join our beta testing program. So microbit.org/testing. So if we just have a quick look there, and go microbit.org/ probably need to type properly, /testing. See our beta program there. And you can sign up as a beta tester. And that will give you an example of all the things that are currently in beta. And you can have a go at testing those and giving us feedback. I showed you already the feedback button in the Python editor. No amount of feedback is too small. We want to hear everything, all your thoughts, all your ideas. And maybe you want to do a university project with us. Maybe you want to do your PhD on microbit. We really love collaborating with educators, technologists who are really grappling with the problems of how we can make microbit the easiest and most effective learning tool. So if you think that sounds interesting, or you're you're doing work adjacent to that, or an affiliated university, get in touch. You can either try help@microbit.org, you can try me, I'm Jonny at microbit.org, and just reach out and say, we're interested in collaborating here. And then all of the Microbit Foundation's code is open source on GitHub. So you can check out the Microbit Foundation GitHub and have a look at our projects there, including the Python editor. And we're working in the open with the Python editor there. So if we have a look at, just have a quick look at GitHub for Microbit Foundation, /microbit. All right, so here's our Python editor next. You can see all of the work that we're doing. If you want to take a look behind the curtain of what we're doing, here's a bunch of our work that we're working on. So you can come and get involved and comment on issues and tell us more about what you think about the editor there. So to summarize, there's real value to making a magical, smooth technological experience. And we think that's a super important part of microbit. When you plug it in, it just works. And students have their first experience of the microbit is success, enjoyment, happiness. But we think it's really important that that magic doesn't get in the way of understanding and exposing what technology does and giving students a mastery of technology. So we want, as you're thinking perhaps about how you teach with the microbit as well, think about that balance. How can we expose and explain technology while giving people a creative, fun, magical experience? There'll be a lot more on that problem in the final session of Microbit Live, which starts in almost exactly 2 hours from now. So go and have some food, I don't know, go for a run, do some yoga, do something, have a break, and then come back for that session. Our opening keynote is Dr. Kate Maloney. I'll be introducing that in almost exactly 2 hours. Thank you very much for everyone that's contributed to today, be that by contributing, listening to talks and commenting on them, or presenting something. It's an absolutely fantastic chance to understand all the incredible things people are doing with microbit. And we're so grateful that you're all here. Thank you very much.